Hello everyone, welcome to my channel. Today we are going to start the part 2 of number systems. Before starting, I am going to give you some corrections on previous video. In this slide, in the earlier video, I have shown that 0.abcde bar will be equal to abcde by 1000000. This is wrong. It should be equal to ABCDE by 99999. Please correct it. Okay, so let us start operations on real numbers. Now, both the rational and irrational numbers satisfy commutative, associative, and distributive laws for addition and multiplication. Both rational and irrational numbers satisfy the commutative, associative, and distributive laws for addition and multiplication. Let us understand this with example. Suppose A, B, C are three rational numbers. These numbers follow commutative law, means A plus B will be equals to B plus A. This is for addition. This follows the commutative law. And for multiplication, A into B is equal to B into A. And these numbers follow associative law. This means A plus B plus C will be equal to A plus B plus C. So we can group it as our wish. This follows the addition. And for what about the multiplication? A into B into C is equal to A into B into C. And what about the distributive law? A into B plus C is equal to A into B plus A into C. That means after this operation, like after adding B with C, if I multiply with A, this will be same as I can multiply A with B, and I can multiply A with C and then add these two. I can multiply A with B, that is A into B, and I can multiply A with C, that is A into C, and then I can add these two. This is same as I can add this B and C and then multiply it with A. This follows the distributive laws. Similarly, for like this also, it follows A into B minus C is equal to A into B minus A into C. Okay. Now, one thing, if we add, subtract, or divide except 0, if we add, subtract, divide any two rational numbers, then we always get a rational number only. Okay, see, for example, if we add two rational numbers, like if I add 2.5 and 1.3, these two are rational numbers. How can we say that these two are rational numbers? After decimal places, this is ending, this is terminating, numbers are terminating, or if it doesn't terminate, if it recurring, then also this will be called as rational number. So if I do the addition, then I get 3.8, this is rational. If I multiply two rational numbers, suppose 1.2 into 0.3, then also I get a rational number. If I divide, then also I get rational numbers if I divide two rational numbers. And if I subtract two rational numbers, suppose 6.1 minus 1, this will be 5.1, this is also rational numbers. So remember this one. However, the sum, difference, quotients and products of irrational numbers are not always irrational. Here what I have told, if I add, subtract or divide except 0, if I suppose if I divide 5 by 0, then it is undefined. That is why I have written except 0. So if I add, subtract or divide any two rational numbers, we always get a rational number only. But in case of irrational numbers, the sum, difference, quotients and products of irrational numbers are not always irrational. This may be rational. How I can get some rational also, like if I deduct root 2 with root 2, I get 0. So this is not irrational, this is rational. But if I add these two, then I am getting irrational number. So this may be rational or irrational. And in another way, if I multiply root 2 into root 2, I get 2, that is rational. Again, if I multiply root 2 with root 3, I get root 6, that is irrational. If I divide root 5 with root 5, I get 1, that is rational. But if I divide root 10 with root 5, this is equal to root 2, and this is irrational. So I cannot always say that from the sum or difference or products or division I can of any two irrational numbers, I can always get irrational only. I can get rational also, rational numbers also I can get. So some important points to be noted from these two examples. So three important points are there. The first is the sum or difference of a rational number and a irrational number is always irrational. And the second one is the product or quotient of a non-zero rational number with an irrational number is irrational. The third one is if we add, subtract, multiply two irrational, the result may be rational or irrational. For the first, the example may be the sum or the difference of a rational number and irrational number. Suppose a rational number is 2.5 and the irrational number is root 3. This is always irrational. Or another thing may be 2 plus root 2. This is irrational. This will always be irrational. And the second one, example, the product or quotient of a non-zero irrational number with a rational number, the product or quotient of a non-zero rational number with an irrational number is always irrational. Like suppose the product of 2 into root 3, this will be equal to 2 root 3. This is irrational. These are also irrational. Suppose if I take 10 by root 2, this is rational number, 10 is rational number and root 2 is irrational. So this will also be irrational. And for the third one, if we add, subtract, multiply two irrational numbers, the result may be rational or irrational, that we have already shown here. That product, quotient, sum, difference of any two irrational numbers may be rational or irrational. Next topic is the representation of square root of any two positive rational number in number line. In earlier class, we have seen how to define root 2 or root 3 in a number line. So this 2, 3, all these are positive integers. So positive, like natural numbers, we have shown how to define the natural numbers, the square root of natural numbers in a number line. So now we want to know how to define other numbers, like positive rational numbers we want to define in number line. So we already know, we have learned about root 2, root 3, root 4, etc. Now we want to know about some other, like say root 3.5, root 4.5, etc. So I'm taking the direct example from NCERT book. Let me take the example of root 3.5. I want to represent it on number line. So let me first put a line, draw a line like this, and I have to take just 3.5 centimeters of length. Suppose this is A and this is B. This AB is 3.5 centimeters. 3.5 centimeters. Okay. Now what I have to do is, I have to take 1 unit length from point B. Please understand, I have to take 1 unit length from point B. That is, this is equal to 1 unit. And let me name it as point C. Okay. So now I have to take half the distance. I have to mark the point of half the distance of this, half the length of this line AC. So what is AC? AC will be equal to 3.5 plus 1, that is 4.5. Now half of AC will be equal to 4.5 by 2, that is equal to 2.25. I have to mark it here in the line 2.25. Suppose it is here, and let me mark it as point O. Okay. Now taking this O as center, and now what is AO? AO will be equal to 2.25, and what about this OC? OC will be equal to same 2.25. Okay. Now considering O as center and taking OA or OC same as radius, let me draw a semicircle. Now next step what I have to do? I have to draw a perpendicular line. Perpendicular to what? Perpendicular to AC. I have to draw a line perpendicular to AC from point B. From point B, I am drawing a perpendicular line to AC, and let us assume that this line is intersecting the arc or the semicircle at point D. Okay. Now this BD is equal to square root of 3.5. The length BD is equal to square root of 3.5. Now if I want to put it in the number line, considering B as 0, B is the origin or B is 0, and so C point will be equal to 1. So what I have to do, taking OD as the radius and point B as the center, I have to draw an arc, and I have to see where it cuts the number line. Suppose this point is D dash, so this BD dash will be equal to square root of 3.5. So in this way I can draw square root of any rational numbers, positive rational numbers. Let me show you. I need to draw square root of x. So how to draw it? Let us generalize the things. Let us draw a line first, taking the first point as A and taking the length x on this line. Suppose this AB is equal to x. So first what I have to do, then I have to take 1 unit length from point B. Suppose this is 1 unit, and this point is C, where it cuts the number line. Now what I have to do, I have to take considering AC is equal to, now what will be the AC? AC is equal to x plus 1. So half AC will be equal to x plus 1 by 2. So considering x plus 1 by 2, suppose this is the point x plus 1 by 2. Considering this point as center, I have to draw a semicircle. Do you get it? This AC, first what I have done, I have drawn a line, this line, then I have taken the length x from A to B, this is x, then I have taken another 1 unit length up to point C, this is 1 unit. Then what I have done, considering AC as the diameter and O as the center, I have drawn a semicircle. Now what I have to do, I have to draw a perpendicular of AC from point B and see where it touches the semicircle. Suppose it touches the semicircle at point D. Now this BD will be root x, and if I want to draw this root x into the number line, considering this B as the origin 0, so C will be 1 unit, and taking B as the center and BD as the radius, I have to draw an arc on the number line. Suppose this is the number line. So this, suppose this is d dash, that means this b d dash will be square root of x. We can prove this bd is equal to root x in some other way also. Consider, let me join this OD also. Consider the triangle OBD. This is a right angle triangle, right? Where OBD is equal to 90 degree. That means, as per Pythagoras theorem, what I can say, OD squared is equal to OB squared plus BD square. Okay. So what I need to know, what I need, what I want to get the result of, what I want to get the result of, I want to get the length of BD. So taking it this side, so BD will be equal to square root of OD square minus OB square. So now what is OD? OD is nothing but the radius. This radius, and what is the radius? This x plus 1 by 2 whole square minus, and now what is OB? OB, this OB is equal to the whole length OC minus BC. You see, OB is equal to OC minus BC. Now what is OC? OC is the radius of this circle. What is that? OC is x plus 1 by 2. And what is BC? BC is 1. We have taken 1 unit from B to C. This is 1. That means, what is this? This will be x minus 1 by 2. See? So I am putting here x minus 1 by 2 whole square. So I have taken out 1, this 2 outside. This is x plus 1 whole square minus x minus 1 whole square. So half into square. So ultimately this will be BD. So by Pythagoras theorem also we can prove that BD is equal to square root of x. So this method is also correct, that we can say. Okay. Now let me tell you some basic things, like what is this? This is called square root of a. This sign is called radical sign, and this is called square root of a, and this can also be written as a to the power 1 by 2. This is same as, this is square root of a to the power half. These two are same. If nothing is mentioned, that means you have to consider 2 is mentioned here, so that is square root of a. Now what is this called? This is called cube root of a. Cube root of a, this can be written as a to the power 1 by 3. This is called fourth root of a. This can be written as a to the power 1 by 4. Similarly, if it goes on, we can write it as nth root of a. This can be written as a to the power 1 by n. Please remember it. Now, see, the next topic is rationalizing the denominator. If denominator of an expression contains a term with square root, cube root, or any other roots, the process of converting it to an equivalent expression whose denominator is a rational number is called rationalizing the denominator. We'll understand it with the example. Like for p by q, this is numerator and this is denominator, you know all. So let us take the example of 1 by root 2. Here this 1 is numerator and 2 is denominator. Now what this denominator contains? Denominator contains an irrational numbers. So the rationalizing the denominator means we have to make the denominator a rational number. How to make it? What we can do simply is, what we were writing it as 1 by root 2 into, we are multiplying on the both side, on the numerator with root 2 and in the denominator with root 2. Okay, so we can do it. So now the new form will be like root 2 by this root 2 square is equal to root 2 by 2. Now you can see that the denominator becomes a rational number, numerator becomes irrational number. Okay, so in the same way, if I get 5 by root 2, I can write it as 5 by root 2 into root 2 by root 2. So this will become like 5 root 2 by 2. What if I get 1 by 2 plus root 3? How to make it? Here the this in the denominator, this 2 plus root 3 is irrational number. If I can make this 3 rational, then the whole denominator will be rational. So how can I do it? Always remember, we have to multiply with 2 minus root 3 by 2 minus root 3. If there in the denominator plus sign is there, just change the sign and multiply on the numerator and both denominator. It is 2 plus root 3, so multiply it with 2 minus root 3 by 2 minus root 3. So what will this become? It will become like 2 minus root 3 by, this is 2 plus root 3 and 2 minus root 3. 2 minus root 3 by, this is a plus b into a minus b. What is this? A square minus b square. So this will be like 2 minus root 3 by 4 minus 3. So this will be 2 minus root 3. Now there is no irrational number in denominator. What is there in denominator? 1. 1 is there. So the same problem, what I will, if I write it as 2 minus root 3, then what I will do? I can write it as 2 minus root 3 into 2 plus root 3 by 2 plus root 3. Our aim is to make this denominator a rational number. So that's why I am writing the same expression by and changing the sign. It will be equal to 2 plus root 3 by this 2 minus root 3, 2 plus root 3. So it's same as 2 plus root 3, 2 square minus root 3 square, 2 plus root 3 by 4 minus 3. This will be equal to 2 plus root 3. Okay. Now we will study the laws of exponents of real numbers. So here let us consider a to the power m. So here a is called the base and m is called the exponents. Here we have considered a, b, n and m are natural numbers, and a and b are the base and m and n are exponents. So what are the formulas or laws are there? Total 6 are there. Please remember these 6. A to the power m into a to the power n is equal to a to the power m plus n. This is the first one. The second one is a to the power m within bracket. It is a to the power m within bracket to the power n is equal to a to the power m into n. And the third one is a to the power m by a to the power n is equal to a to the power m minus n. And the fourth one is a to the power m into b to the power m is equal to ab whole to the power n. And a to the power 0 is equal to 1, and 1 by a to the power n is equal to a to the power minus n. These formulas you have to remember, and I am taking some examples for this. For the first one, I am taking an example. Say consider here in the first one, where a to the power m into a to the power n. Here see the base, this base are same but the exponents are different. So considering the base same, 5 to the power 4 into 5 to the power 2. Here the base are same but the exponents are different. The example of 1. So what will be, as per the first law, what will be this? A to the power m plus n. What is a? A is 5. 5 to the power m plus n. This is m and this is n. So 5 to the power 4 plus 2 is equal to 5 to the power 6. Now go to the second one. Let me write as 5 to the power 4 within bracket to the power 2. So here we can write as per the second formula. We can write what we can write. This is a to the power m within bracket to the power n is equal to a to the power m into n. So here this 4 is m and 2 is n. So it will be m into n. So 5 to the power 4 into 2 is equal to 5 to the power 8. Okay. Now the third one, a to the power m by n. I can write it as 5 to the power 4 by 5 to the power 2 or 5 square. What will be equal? This will be equal to a to the power m minus n. A is 5 to the power m minus n. 4 is m and 2 is n. 4 minus 2. So 5 to the power 2 or 5 square. Let me take a fourth example. Consider a as 5 and m as 3 and b as 7 and m will be 3. So this is similar to this fourth one. 5 to the power 3 into 7 to the power 3 will be equal to, so what is a to the power m into b to the power m is equal to a into b whole to the power m. So here it will be 5 into 7 to the power 3, that is equal to 35 to the power 3 or 35 cube. And the fifth one, if I write 5 to the power 0, this will be equal to 1. And now sixth one, if I want to write 5 to the power 1 by 5 to the power 4, as per this law it can be written as 5 to the power minus 4. Okay, remember a to the power m by n, this can be written as n root of a whole to the power m, or this can be written as n root of a to the power m. And you have seen a to the power mn. Another one thing also I can say, if I write a to the power m n and if I write a to the power m to the power n, are these two same? No, these two are not same. Remember it. Suppose if I write a to the power m n into a to the power m, this will be equal to a to the power m n plus m. It can be written as a to the power, I have taken common m into n plus 1. But if I write a to the power m to the power n into a to the power m, then I have to write it as a to the power m to the power n plus m, like that only. Okay, so I think you have understood. So in this chapter we have covered all the theory of number system chapter. In the next video we'll be doing some we'll be solving some problems. So take care, thank you, and please support the channel.